In our previous lessons, we've established that triangles can be categorized into two based on their interior angles. For a triangle whereby one of its interior angle is 90 degrees, it is called a right angle triangle. So let's call this side XY. Let's call this side H. No, let's call it ABC instead. ABC. If we are considering this angle theta, let me this angle theta for example. This A is the opposite, this is the hypotenuse, and this is what? The adjacent. And according to Pythagoras theorem, it said that C squared, which is the hypotenuse, equals to A squared plus B squared. Pythagoras theorem. Then we should also know the three ratios: sine theta, cos theta, and tan theta. So what is sine theta from here? Opposite over hypotenuse. What is cos theta? The adjacent over hypotenuse. What is tan theta? Opposite over adjacent. Now the problem now is, what if the triangle is not a right angle triangle? For example, suppose we have something like this. Obviously, this triangle is not a right angle triangle. Let's label the side as X, Y, Z. Let's put the Z here. What is the connection between them? What can we do? It is very easy for us to work with right angle triangles. So this is what we'll do. Let's draw a perpendicular line by producing this Y. This 90 degrees. So let's call this side A. This small side B. And this side Z is the hypotenuse. Our aim is to know the connection between X, Y, Z. So we have two right angle triangles here. First is this small one here. And from here we can use Pythagoras theorem here and say Z squared equals to A squared plus B squared. Right? Yeah. From this small one. Then from this giant right angle triangle, this 90 degrees. So this X is the hypotenuse. So it means this hypotenuse S squared equals to this A squared plus the whole of this, which is what? Y plus B all squared. So from here, this becomes A squared, X squared equals to A squared. If we expand this, we have what? Square the first, plus twice their product, plus square the second. Now from here, we can say S squared equals to, I can write on this first, A squared plus B squared plus Y squared plus 2BY. Then from here, we've already established that Z squared equals to A squared plus B squared. So we can come and write S squared equals to, instead of writing A squared plus B squared here, we replace it with what? Z squared. That is Z squared plus Y squared plus 2BY. Now, our aim is to know connection between X, Y, Z. X, Y, Z. Y, but there's still B here. We need to replace this B. We have to eliminate this B. How? Let's come up to this shape. Let's suppose for this triangle, this angle is given to be, let's say, theta. If this angle is theta, let's call this angle here alpha. Our aim is to replace B with Z. So this opposite, this is the adjacent, this is the hypotenuse. So if we are considering the adjacent hypotenuse, that's cos. So this cos alpha equals to, what's the adjacent? B over Z. From here it means B equals to Z cos alpha. From here, if we add theta and alpha, we must get what? 180 degrees. And from here, we can say alpha equals to 180 degrees minus theta. So B equals to Z cos, instead of writing cos alpha here, we write what? Cos 180 degrees minus theta. One of the identities in trigonometry is that cos 180 minus theta is the second quadrant and is negative of the equivalent of the first quadrant. So cos 180 minus theta is something as what? Minus cos theta. So for me it means B equals to minus Z cos theta. Let's now come back here and replace this B with minus Z cos theta. So from here we have S squared equals to Z squared plus Y squared plus 2. What's B? Minus what? Z cos theta. Time what do you have there? 1. So this S squared equals to Z squared plus Y squared minus 2 ZY cos theta. So this is the connection between them. So from this triangle, let's draw it again. From here, if this is X, this is Y, this is Z, and this is theta. This side we are looking for. Let's suppose Y and Z are known. To get this X, we apply what we call cosine rule. This rule we have here is called what? Cosine. Because our final answer is in terms of what? Cos. Established. But most times, the sides are not labeled X, Y, Z. They are normally labeled as A, B, C. But it doesn't matter. So let's call this side A. Let's call this side B. Let's call this side C. The angle facing A is usually labeled capital A. From here, we can follow the same pattern. Following this pattern, we can also write that instead of X here, we can say A squared equals to, instead of writing Y, or instead of writing Z, we can say equals to B squared plus C squared minus 2 ZY BC. Cos theta is down that face X. We say down that face A is what? Capital A. Cosine rule. So cosine rule is used whenever two sides are known and you want to get a third side, provided that the angle facing this is known. Or to get a particular angle in a triangle, if all the three sides are known. For example, if you want to know side A, the angle A, you need to know side A, B, C. So we write this A first. If our aim is to get B, we must know the angle that faces B, capital B. So if one wants to get this B, we must know this angle. In that case, we now write B squared equals to A squared plus C squared minus 2AC cos B. If our aim is to get this C, this side, this C, we have to know the angle that faces it, this big C. Then we apply C squared equals to A squared plus B squared minus 2AC cos capital C. Cosine rule. Then we have the other one called the sine rule. Sorry, there's a mistake here. This ought to be 2AB. Cos C. Now, the twin rule, sine rule. Second, the twin rule. The first one is cosine, the twin is the sine rule. Now, let's label in general. Let's label this side as A, B, C. The angle facing B, let's call it big B. The angle facing A, let's call it big B. Same thing, let's draw out a 90 degree. Let's call it side H. Now look at this. If I do sine B, sine is opposite over hypotenuse. For this one, the opposite is what? H over what? A. Now, let's now consider this small triangle, this right angle triangle. If the angle here is A, the remaining one is what? 180 minus A. So if I do sine, from here we can multiply and say our H equals to A sine B. Let's call equation 1. So for this one, we can say sine 180 degree minus A. So for this angle, this is the opposite, H over its own hypotenuse is this B. But we should know that second quadrant, in the second quadrant, sine is always positive. So meaning sine 180 minus A is same thing as what? Sine A. You can also sine A equals to H over B. From here, can multiply H equals to B sine A. Equation 2. Now, if you check equation 1 and 2, H equals to this, H equals to this, so we can equate them. So it means A sine B equals to B sine A. Now let's divide both side by AB. Let's divide this side by AB, this by AB. In this case, A cancels A, B cancels B. So therefore, using this side, I can say sine A over A equals to sine B over B. These are called sine rule. Let's draw a diagram again. If this side is, if this angle A, side A, this angle B, side B, then it means sine A over A equals to sine B over B. In fact, for this third angle, capital C, this side small c, you can also say this is also equals to sine C over C. We can also establish that one for angle C. So that is what? Sine rule. So sine rule is used for a triangle if we have two sides and two angles and one of them is unknown. So let's suppose we have a triangle like this. This angle is given to be 20. This side is given to be 12 meters. You want to get the value of this side. To get the value of this side, you must be given this angle here. Let's say this angle here is 100. So we can apply sine rule here. So it means sine 100 over x equals to sine 20 over 12. From here we can get x. You can just multiply. From here you can multiply. It means x sine 20 equals to 12 sine 100. From here x equals to, divided by sine 20, 12 sine 100 over sine 20. From there, the value of x can be gotten. We can take as example 1. So to get unknown side, if you know the angle facing it, then another angle and the side facing it. That's what we can look for. We can use sine rule. Example 2. This time around, we are looking for unknown angle. If you are looking for a particular angle, you must know the side that faces it. Before you can use sine rule, let's call it 25 meters. But you must be given a side and the angle that faces it. You see that you are given this side and this angle, or this side and this angle. So let's suppose you are given this angle and this side. This side is given to be, let's say, 30 meters, and this angle is given to be, let's say, 60 degrees. So in this case, we just do sine the angle alpha over 25 equals to sine 60 over 30. From here, we can just multiply both by 25 times 25 sine 25. So this can cancel this. So it means sine alpha equals to 25 sine 60 over 30. From here, we can get the answer here in decimal. To get alpha, we'll do sine inverse on both sides. So we'll take sine inverse of sine alpha, sine inverse of 25 sine 60 over 30. Sine inverse takes sine away. So therefore, our alpha becomes, you can press shift sine calculator, 25 sine 60 over 30. This will give you your final answer. So sine rule is used to get unknown side when the angle facing is known. Given a side and another angle facing each other. Or unknown angle, given the side that faces it, then an angle and a side that is known. So we are always dealing with two angles, two sides facing each other. Two angles, two sides facing each other. The angle faces the side, this angle faces the side, same thing. That is when we can apply what? sine rule. Is that clear? Now for cosine rule, we can use cosine rule to get unknown side if the other two sides are given. For example, let's suppose we are looking for this side, let's call it x. This is given to be 10 meters. This one has, let's say, 12 meters. If you are given two sides of a non-right angle triangle, to get the third side, you must give two sides and the angle facing that side. You have to get it. Without the angle facing it, you cannot get it. Let's call this angle 100. Then we cannot apply cosine rule. So the side you are looking for, you write it first. S squared equals to 10 squared plus what? 12 squared minus their product. 10 times 12 times cos the angle 100. Okay, thanks for that. Minus 2. Square this minus twice their product, then cos the angle. So from here, our s squared becomes 100. Please, 12 squared is what? So 10 times 12, 120 times minus 2, minus 240. Then cos 100 should give you minus something. Minus 0.1, 4 decimal places. 1736. So from here, s squared becomes 100 plus 144 is 244. Minus times minus plus. Now 240 times 0.1736. 41.6756. Add it together. Plus 244. Plus 244. 285. 5. So to get x, square root both sides. All square root of 285.6756. 16.901. That's 90 meters. So that is the value of what? X. We use cosine to get unknown side, given the other two sides and the angle between them, or to get a particular angle, given the three sides. If we have three sides of a triangle, let's say we have this. Let's call this one example 4. You want to get this angle, let's call it alpha. Using cosine rule, you must know the three sides without knowing any of the angles. So let's go, this side is 15, this one is 16, and this one is 12 meters, meters, meters. In this case, we can also apply cosine rule, but don't do any mistake here. You know, if you are looking for the side, this is the angle we are going to consider. Now, since you are looking for this angle alpha, this side is what you are going to consider. So we are writing this 12 first, because we are considering this angle. So we are going to write what? 12 squared equals to 15 squared plus what? 16 squared minus twice their product. That's 15 times 16. Then cos alpha. So 12 squared equals to 15 squared plus 16 squared minus 215 times 16, then times cos alpha. From there, you can get the value of alpha yourself. Sometimes you can have a combined question where you need to apply both sine and cosine rule together. After that, we now move to application, which is mainly bearing and distance. Let's finish this question. 12 squared is what? 15 squared, 16 squared, 2 times 15, 30 times 16, then cos alpha. We can write 144. Addition of these two. We can take the whole of this to this side. So the minus turns to plus. Equals to 481 minus what? So subtract. So to get alpha, you can divide this by 480. Divide this by 480. This side by what? So what's cos alpha here? 70. 2. To get alpha, we'll take cos inverse of both sides. So just press shift cos. And the value of alpha is? That is the final answer. Now let's check out this question 5. We have to look for two angles, alpha, beta, y, and x. So when we look at this very well, let's suppose we want to get x. So to get x, this x belongs to two triangles, the big one. For the bigger triangle, to get the value of x, we must always know the angle that faces it, either sine or cosine rule. If it's sine rule, you need to know this angle. If it's cosine, you need to know this angle. So meaning you can never get x without knowing alpha. So to be able to get x, can we get alpha? Let's see. Alpha belongs to this triangle here also. We know the side that faces alpha as the confidence. Then to apply sine rule, we need another side and the angle facing it. So we have this side 8 and the angle facing it. So we can use sine rule. So we can first get alpha using sine rule. So we do what? Sine alpha over what face alpha? 16 equals to sine 25. What face 25? 8. So we can bring 16 here. So from here it means sine alpha equals to 16 sine 25 over 8. 8 is still as 2. That's 2 sine 25. Everything here in decimal is what? Zero 0.8452. To get alpha, we'll do sine inverse on both sides. So press shift sign and put this value in front. You get alpha to be which can be approximated as 57.70. So alpha is 57.7. Now that we already know alpha, can we get x? We can only get x. We know the angle. We need to know the other two sides to use cosine rule. This side is known, but we don't know y. So we cannot get x until we get to y. So next is, can we get the value of y? Now let's come back here. To get y, we must know the angle that faces y also. To get y, we need to know beta, right? But since we already know alpha, we have this angle. Using some angle of the triangle, we can get the value of what? Beta. So from here, beta plus alpha plus 25 must give us what? So what is alpha? 57.7 plus 25 equals to, so add this together, equals to, so what is beta? And that's what? 7.3. So we've gotten beta. So the next is for us to get y. Because we already know the angle facing y. Then we have this. So using sine rule again, we can say sine what? Sine beta, which is what? 97.30 over what? Y. Equals to sine 25 over 8. So from here, our y equals to 8 sine this to this. Divide by what? Final answer straight. .78. So two decimal places. Then our aim was to get x first, but we see that we cannot even get x first. X will be the last we are going to get. So now, can we get x now? Yes. How? If you check this small triangle, we can't get value of x at all. What does it mean? That although we know these two sides, 7 and 16, to get x we need to know this angle facing it. If we have this angle, we can apply what? Cosine. But instead of that, we can use this whole triangle. This side is 15, 8 plus 7. This side is y, which is 18. You want to get x, this angle is alpha, which we've gotten already with 7.70. So let us draw a big triangle. This is x. Everything here is 8 plus 7, 15. Everything here is y. And y is 18 point what? And this angle alpha is what? So we cannot apply cosine rule. Using cosine rule, x squared equals to 15 squared plus 18.78 squared minus twice their product, 15 times 18.78. Then cos the angle between them. 15 squared is 225. 18.78 square will give us this. Then multiply 2 times 15 times 18.78 times cos 57.7. 301.01054. So add this, subtract this. So s squared equals to so from here x is square root of 276.64. So finally x equals to so we've gotten alpha, beta, y, and x. We apply sine rule 3 times, then cosine rule once. Although we could have used sine rule in total, because here we can get x if we know this angle, which we can get because this angle is a straight line. We know beta, we can get this small angle here, but we cannot say apply sine rule because although we know this angle, we can get this side. For this side, we need to know this angle, and we are not given. And there's no way we can get this angle too. So we are forced to use cosine rule to get the value of x. And this is the end of sine and cosine rule. What next is application of sine and cosine rule, which is bearing and distance. Concept of bearing and distance. Bearing actually means direction, and I believe you all know what distance is. It's the length between 2 points. So now, before we start, let's revise sine and cosine rule. If we have a triangle with 3 sides, let's call it A, B, C. The angle facing A, let's call it capital A. The angle facing B, let's call it capital B. And the angle facing C, let's call it capital C. So for sine rule, the sine of an angle, let's say A, divided by the side facing it, small a, equals the sine of another angle B, divided by the side facing it, B. You can even compare with the third angle, sine C over small c. So this is sine rule. Sine rule. The sine rule is used when you are considering 2 angles, 2 sides, if one of them is not known, and the angles and sides are facing each other. Then we have the cosine rule. Cosine rule is normally used to get an unknown side. To get an unknown side, let's suppose B and C are known, but we want to get A. To get A, we need to know the angle that faces A. So from here, cosine is still at what? A squared equals to B squared plus C squared minus 2BC cos A. This is cosine rule. Cosine rule is used to get an unknown side if the other 2 sides are known and the angle facing it, or to get an unknown angle if the 3 sides are known. So we can get the value of A if we know ABC, but we have to make this small a the subject here. Now let's move to bearing. First, bearing. Bearing means direction. Bearing means direction. So, and bearing in mathematics can be in 2 forms. The first one is the compass bearing. For compass bearing, we use the cardinal point. And we know basically we have 4 cardinal points. We have the north and south. We have east and west. This is east and this is west. So suppose we are told that a body moves in the direction of 60 degrees north of east. Not 60 degrees east, meaning 60 degrees east of north. So this can also be written as what? 60 degrees east of north. Meaning from north. Our reference is always from north or south, from the vertical axis. So from this north, we know from here to here is 90. So 60 is not up to 90, then we'll move this way, we'll turn, we calculate 60, then we'll draw this line. So if this angle is 60 degrees, then this is the direction or the bearing of that particle moving, of that object moving. So that's what we want to show on that one. Let's say north 45 degree west. So that's what? 45 degree west up north. This is north, this is west up north. Then we'll calculate 45 degrees. Then we'll draw it. So this is direction for the second particle. Let's call the particle A, this particle B. For particle C, let's suppose we have south 30 degree west. So this is south, downward. It means we are going to draw our direction downward towards the west. So we measure the 30 from here. The reference is always to the vertical, like I said. The 30 degrees move this way. This is the direction of particle C. This is particle B. This is particle A. So south 30 degree west is same thing as what? 30 degree west up south. Then let's say we have point D. Point D is, let's say, south 70 degree east. So that is what? 70 degree east of south. This is south. This is east of south. From this south we measure 70. Then we draw the direction. This is the direction of D. A, B, C, D. So if you are given the direction, the bearing, we know how to show that from a particular point. Apart from the compass bearing, we have the three-figure bearing. We have the three-figure bearing. For example, we are told that the bearing of a particle, let's suppose you have a particle X, let's say W, X, Y, Z. For W, for three-figure bearing, we can be told that W is 200 degrees. We can be told that X is, let's say, 150 degrees. Or 075 degrees. Or we can have, let's say, 315 degrees. These all got three-figure bearing. Three-figure bearing. So in this case, you won't be told whether it's north, south, east, or west. But you have to know how to transform three-figure bearing to compass bearing, because it's easier to solve using compass bearing. So let's start with this 200. First, let's come back to this diagram here. We know that between the north and east, total angle is 90. So from here to here is 90. From here to here is two right angle, 180. From here to here is 270. And from here, 360. So this 200, for example, is more than 90, is more than 180. Then it must fall to the third quadrant. This is first quadrant, second, third, fourth. We start from the north, then we move clockwise. So for this 200, for the 200 degrees, we should do something like this. We start from the north, then we move clockwise. So this is 90, 180. If we remove 180 from 200, that is 20. So this is 180 plus extra 20. So we'll draw it out this way. So this is the bearing of W. So the whole of this angle here is 200. But what we actually need is this acute angle, which is what? 20 degrees. So from here it means this 200 degrees is equivalent to south 20 degree west. South 20 degree west. Now let's take this 150 for example. 150 is more than 90, but it's not up to 180. So we can draw something like this. So we want to represent 150. So we'll move 90, but it's not up to 180. So if we move 90 from 150, we have 60 left. So this is 90, then we have remaining 60. So we can draw it this way. This is the bearing or direction of point X. The whole of this angle is 150. If it is 90, the remaining one is 60. So it means 150 is equivalent to southeast. South 60 degree east. So for this 75, it's not up to 90. So definitely it will be part of what? Northeast. Because 75 is from here to here. Let's use this one for that purpose. This one for the 75. So 75 is up to 90. So it means 075 degree is equivalent to north 75 degree east. So this is the direction of point Y. Then lastly, 315. For the 315 degrees, this is 90, 180, 270. If we remove 270 from 315, that will be 45. So this is really 45. So this is going to be the direction of our point Z. If the whole of this is 315, from here to here itself is 270. So the remaining one is 45. But we have to reference to the north, 45. So it means 315 is equivalent to north 45 degree east. But there is no problem here. What we did here is actually wrong. Why? Because we have to reference to the vertical. So this 60, we have to reference to this one. So this is referred to the horizontal, but it's more to the vertical. So if it's 60, the minimum must be 30 degree. So it's actually south 30 degree east. Let's check for this one. Okay, this one is correct. This trend is to the vertical. This 30 to the vertical here. And this one for 20 to the vertical here. This 75 is to the vertical here. So anytime we are given three-figure bearing, we should know how to convert it to compass bearing. Because it's easier for us to work with acute angles. So what about direction? For example, let's go to this first point. North 60 degree east. So this is the direction, the bearing. What about distance? If you are given the direction of a body without the distance, we can only know the direction. Where the body, the path of motion, but we won't know where the body stops. So let's suppose you are given this 60. So it means that part can fall any point here to infinity. But if you are given a distance, let's say 2 meters. So on this path, we measure 2 meters. You can use scale. Measure 2 meters, then note it. So know where the body will point at. So to know exactly where a body falls, the point where a body is, we need to know its direction, bearing, and its distance. Its direction, we've done that already. For the bearing, for the distance, we measure. We can use scaling. For example, we are told that a body moves 2 kilometers south, 50 degrees east. There's no way you can draw 2 kilometers on your note because it's too much. So you can use scaling. Maybe for that 2 kilometers, let 1 kilometer represent 5 centimeters or represent 2 centimeters. So every kilometer you draw 1 centimeter in your note. So now, I believe by now we know what bearing and distance is. Let's now move further. There is a slight error here. So this direction is actually between north and west. So this is 45 degree west, northeast. Let's consider this question. If the bearing of P from Q is 210 degrees, what is the bearing of Q from P? Now, I want you to note this. In every question on that bearing and distance, you have to know the origin, where you are starting from, your start point. And how do you know your start point? One for the word from. Here, the question says from Q. So from Q, it means your origin is Q. So let's say this Q. On this point, draw the vertical and horizontal point, or axis rather. So 210, let's go. 90, 180. From 210, if we remove 180, that is 30. So we're bringing 30 here. So from this Q, this is the bearing or direction of what? Of P. So this direction of P. So let's suppose P is here. So this 200 is actually equivalent to what we have is 30. That's southwest. South 30 degree west. So the direction of P from Q is actually 210. Which is 210, not 200. Which is south 30 degree west. Now the question now says, what is the bearing of Q from P? From P now, if you have to start from P and not move to Q, what is the bearing? So from Q to Q, from Q to P, this direction. P to Q, this will be the same direction, but backward. This is P to Q. Or Q from P. Q from P, meaning from P you are moving. This is the direction. And how do you know the direction? Check from here. We start from the north of Q to the line joining them. So this is the line joining P and Q. In this case, we start from P to the line joining them. This is what we need. Then when you check, this angle 30 and this, they are alternate. So if this angle is 30, this angle is also what? 30. But now it's between north and east. So it means the bearing of Q from P is actually what? North 30 degree east. Although the question is given in three-figure bearing, so it's best your answer is also in three-figure bearing. So in three-figure bearing, this angle is just what? 30, right? As 0, 3, 0 degrees. That is it. Now let's go to another question. The bearings of two ships, A and B, from a port P. So port P is the origin from port P. So let's say this is our port P. So you have two ships A and B. The bearings are 225 and 116. So it means A is 225. For 225, we go 90, 180 is not 270. So 270 minus 225 gives what? So this is 180 plus 45. So we are going to use the 45 here. Note, this represents the 225. Like I said earlier, using the arched angle will make it easier. So this is the bearing of ship A. Ship B is 116. 116 is more than 90, but it's down to 180. So remove, we want to write 116 now. 90. From 116, if we remove 90, it remains what? 26. So we have to draw the 26 and come here. So this angle here is 90. This one here is 26 degrees. So this is B, this is A, this is B. But what about the distance? We don't know yet. Let's continue. Ship A is 3.9 kilometers from B. So this is A, this is B. We don't know where they stop. So let's suppose A stops here and B stops here. It means the distance of A to B is 3.9. But we are not certain if this will be the correct bearing. Let's continue. 3.9 kilometers from B. So meaning if this is A. To know the direction of A, we have to start from B. So let's say this is our B. From B, the bearing is what? 258. 258. So meaning from this B, we are going to draw 258. Let's do that. It's not 270. 90, 180. If we remove 180 from 258, that will be 78. So from here we calculate 78 degrees. Then after that we join this point. It's not straight enough. So this angle here is what? 78 degrees. So it means here is not the true. These two lines are to meet ordinarily. So let's shift this one up a bit. 78. 78. And this one should go down. But if you have to draw these two, it will be outside the board. So let's just bring this one down a bit. 45. Let's take this still at 45 degrees. This is now our point A. This is point A. This is the port P. This is point B. This angle here is 78. So we are told that distance between A and B. A is 3.9 kilometers from B. 3.9 kilometers from B on the bearing of 258. And from this 58 is how we got this 78. This 26 is just 116. This 45 is from this 225. So what's the question? Calculate the distance of sheet A from P. A from P. We are looking for this. Let's call it AP. Now, how can we get P? This triangle is not a right angle triangle. So we either use sine or cosine rule. But obviously here we cannot use cosine rule. Why? To use cosine rule, to get a sine, we must know the other two sides. We are not given PB. We are only given what? This. So we have to use sine rule. And for sine to get AP, we need the angle facing it. This is the angle facing AP. We need to get it. Although we are not given, but we can get from what we are given already. Now look at this. From this point to this point, total angle here is 90. From 90, let's move 78. That is going to be what? 12 degrees. Now when we check, if this angle here is 26, definitely this angle will be 26 because they are alternate to each other. So if this angle is 26, this angle here is also 26. So if we add 26 and 12, we are going to get 38 degrees. So with the angle that faces AP, we know it already. We are given 3.9. That's AB. So we need the whole angle facing AB also. We need this whole angle. Now this angle is already 45. So this other part, you can get it. Why? Everything here is 90. From 90, if we remove 26, that will give us what? 64. If we add 64 and 45, we are going to get 109. So it is as though we have this triangle this way. We are looking for this side AP. We have this side 3.9 kilometers. We know the whole of this angle to be 109. And we know the whole of this angle to be what? 38. So this time around we apply what? Sine. So we do sine 38. Divide by what face 38? AP over sine 109. What face? That's 3.9. From where we make AP the subject, AP equals to 3.9 times this sine 38. This will come beside it, then on the other side. If you press directly your calculator, you get AP to be equals to 2.53 kilometers. Final answer. Question 3. An airplane flies from a town X. From town X. So our diagram will be from X. So let's say this is X here. It flies from this town X on a bearing 45 degrees northeast. 45 degrees. To another town Y. You don't know where Y is. Let's just put a point on it around this line. Let's say this point Y. A distance of 200 kilometers. It then changes course and flies to another town Z on a bearing 60 degree. That's 60 degree east of south. So this is south, 60 degree east. Then we'll draw this. So this is the direction of what? Z. Direction of Z. So this angle is 60 degrees. If Z is directly east of X, this is X, this is east of X. So if we draw the east of X, say Z is directly east of X, so meaning Z is somewhere here. What's that question? calculate to three significant figures the distance xz, xdz, xz. We are labeled xz. Let's call this xz. Finish. Now, definitely we cannot see use cosine rule. Why? This third side is not given. So use sine rule again. To use sine rule, to get xz, we need to know the whole of this angle. Now look at this. This is 45. Go this way, come down. Something like this. Since these two lines are parallel to each other, these two angles must be equal. So here, this is also 45 degrees. In total, the angle here is what? 105 degrees. What next? 200 is given, so we need to know this angle. How can we get that? Now look at this. The angle here and this angle must be equal. We have something like this. Parallel to each other, this and this must be equal. So if this angle here is 60, definitely this angle is 30, because everything here is 90 degrees. Then this 30, this angle is also 30 degrees. So from here, we can apply sine rule. Why? We can say sine 105 over, what is the sine of 105? xz equals to sine what? Sine what? 30 over 1 is 30, 200. So from here directly we can get our xz to be 200 sine 105 divided by sine, that's 400 times sine 105. So from here xz is going to be 6. 0.67 386.37 kilometers. So to 3 SF, so this is approximately 386 kilometers. To 3 significant figures. Distance, the distance from y to xz. This is xz, this is y. So distance between this point from this line. Most times, if you are told to look for distance from a point to a line, they are actually talking about the perpendicular distance of that point to the line. So when we say perpendicular, but that's what will be our assumption. Because someone else can draw from this point to this point, or from here to here. But the correct one is the perpendicular distance. Let's call it h. So from here we can make this triangle. Distance of y to xz, we'll call it h. This is 90 degrees. This is 200 kilometers. And this angle here is going to be 45 degrees. From here. So to get h, we use trig ratio because this is not a right angle triangle. Opposite is not given. We have the adjacent and the hypotenuse, and that is cos. Cos 45 is the adjacent over hypotenuse. From here, h equals to 200 cos 45 degrees. Cos 45 is root 2 over 2. So h is 100 root 2 kilometers. To 3 SF, for 1. And that is the answer to question 3. Let's move to question 4. 3 ships P, Q, and R are at sea. The bearing of Q from P. So we are starting from P. Solution. Let's say this is P. From P, the bearing of P is 030. So let's say Q is somewhere here. And this bearing is 030. This is Q. And the bearing of P from R. But the question is, where is R? Is R here? Here. But R is not originated from R. So you have to start from R. But we are not told where R is. How are we going to connect? Okay. Let's just draw it here. Let's say this is our R. For 300, go like this. 270, 300. So if we want our I to join P, because I said the bearing of P from R, if we want R to join P, then this R should be somewhere here. So I can join P here. So let's put our R somewhere here. This P. This is our R. So 300, 90, 180, 270. That will be remaining 30. So from that 30, we join this to this. So it means this 270 and this is what? 30 degrees. What's that the question? If PQ is 5, PQ is 5, and PR is 8. So PR is longer. So let's make this one a bit longer. Although it doesn't really matter. But to make our diagram more realistic, this is our R. This is 30 as we've done before cleaning. This is 8 kilometers. Calculate QR. This Q, this R. We are looking for QR. Obviously, two sides are known. We are looking for the third side. So here, definitely, we are going to use what? Cosine rule. But to use cosine rule, we need to know this angle. We are not given, we have to look for it. If this angle here is 30, definitely the minimum was 60. For this one, this is 30. Go like this, go like this, go like this. So this is what also. So what is this angle here? It means we can even use Pythagoras theorem straight. Because this is not a right angle triangle. But let's assume we don't even know it's right angle triangle. We can still apply cosine rule. So from there, using cosine rule, you have to state it. Using cosine rule, the square of QR, QR squared equals to PQ squared plus PR squared minus 2 PQ PR cos, what is angle here? Cos P. We are looking for QR. QR squared equals to, what's PQ? 5 squared plus 8 squared minus 2 into 5 into 8 cos 90. Cos 90 is 0. So everything here disappears. So it's as though you are still using Pythagoras theorem. So QR squared becomes 25 plus 64. QR equals to square equals to 89. Then QR is the root of 89. So QR is
9.43.
43 what?
3.
Kilometers. So we go to the first part, QR. Second part, the bearing of R from Q. The bearing of R from Q, meaning if you are starting from Q, I want to go to R, what is direction? From Q, we are going to R. Q to R. So this is, we are looking for this direction. So from this Q. So the Q is our origin. So we are going to start from the north of Q. We'll move clockwise to the line joining them. So this is angle we want to get. Let's call it alpha. If we can get the value of alpha, we are done. How can we get alpha? There are many ways. Look at this. From here to here, total angle here is 180. So if we can get this small angle here, let's call this angle theta. So let the bearing of R from Q be alpha. From there, alpha plus theta must give what? 180 degree. So therefore, alpha equals to 180 degree minus
Theta.
So our aim is not to get theta. Because if we know theta, we know alpha. How can we get this theta? This is just a part of this angle. Let's get this many angle. This many angle is going to be what? Look at this. So if this angle is 30, this angle is also what? So it's as though the whole of this angle is known to be what? 30 plus alpha. let's get the whole of this angle. Then from there we can get theta itself. How can we get this whole angle? We can use, since this is a right angle triangle, we can use trig ratio straight, or we can see sine rule. We can say sine of this angle over this. So we can say sine, this angle is 30 plus theta over 8 equals to, can you sine 90? Sine 90 over QR. What's QR? 9.43. From here, it implies that sine 30 plus theta equals to 8 sine 90 over 9.43. Sine 90 is 1. 1 times 8 is 8. Now divide 8 by 9.43.
0.8485.
4 decimal places.
0.8483.
So you have to take this sign away. So do sine of both sides. So it means 30 plus theta equals to sine inverse of 0.8484. From here it means 30 plus theta equals to 58.03. So from here what's theta straight? 58 minus 30.
28.03.
Now that we know our theta, let's come back here to get our alpha.
Alpha equals
So alpha is 180 minus theta. What is theta now?
28.03.
So therefore our alpha becomes
151.97.
we are not told to get alpha, we are told to get the bearing of R from Q. Since we've already declared here that the bearing of R from Q is alpha, so by getting alpha, we got to the answer already. But if you didn't declare alpha at the beginning, when you are done, you have to declare what alpha stands for. But it's better you declare alpha at the beginning. So the bearing of R from Q is 151.97 degrees.